Today we're going to be talking about section 10.5, more on division of radical expressions. So the first part of this is talking about rationalizing our denominators. The reason that we have to rationalize a denominator is because we cannot leave a radical in the denominator. So in the bottom of a fraction, right? So let's look at example 1 to start. First, I'm going to separate out and rewrite this as root 11 over root 2. I can't take the square root of 11. I can't take the square root of 2. So there's nothing else I can do except for rationalizing my denominator. The way that we're going to do this, all right, is we're going to follow the rule. If I have root A over root B, we're going to multiply by root B over root b, which is effectively multiplying our fraction by 1. And so when I do this, I get the square root of a times b over just b, right? So here, when I do this, I'm now going to multiply the top and bottom of my fraction by root 2. When I do this, root 11 times root 2 is root 22. Root 2 times root 2 is root 4. But what is the square root of 4? It's 2. And so now we have rationalized, and this is our answer, the way that we leave it. And we know it's our answer because there is no radical left in the bottom of the fraction. All right, so now let's look at another one. Okay, so this one, next example is a little bit different because the index is 3. All right, and so if I have an index of 3, I'm now going to do it the exact same way. I'm going to separate it out. Don't drop your index, what it do to you, right? So I have the cubed root of 2 over the cubed root of 25, all right? Now, when I look at this one, I know that because it's a cubed root, I'm going to need a group of 3 in the denominator. So I'm going to rewrite it as the cubed root of 2 over the cubed root of 25 is just 5 to the second power. So all I did going from here to here is I rewrote 25 as 5 to the second power. Now I'm going to multiply the top and the bottom by the cubed root of, because this is 5 squared, I need one more 5 to make it 5 cubed, all right? So that way the exponent is the same as the index. So I'm going to multiply by the cubed root of 5. So when I do this, I now have the cubed root of 2 times 5 is 10 over the cubed root of 5 squared times 5 is 5 to the third power, so 5 to the third. And so now what happens with our index and our exponent? They're going to cancel. So now I have the cubed root of 10 over 5. There's no longer a radical in my denominator, so I'm done. That's my answer. Go ahead and try these pause the video and try these next 2 examples on your own. Great. Now let's look real quick. For this one, you should have ended up with root 10 over 5. All right, for this one, you separate it out over, rewrite 4 as 2 to the second power. So all we're doing is we're rewriting 4 as 2 to the second power. And then I have the cubed root of 5 over, all we're going to do here now is multiply the numerator and the denominator by the cubed root of 2, because 2 squared times 2, these right here, is 2 to the third, and we want this exponent here to be the same as the index. And when we do this, we end up with the cubed root of 10 over the cubed root of 2 to the third, and so now we end up with the cubed root of 10 over 2, because the cubed root and the 2 cancel. That's all of your notes for today. I will post an assignment. Please let me know if you have any questions.